Hi students, this is AJ sir. Let's study 9th standard ICSE Math, exercise 5D and 5E. For exercise 5D, we have to remember two formulae. That of a cube plus b cube being a plus b a square minus ab plus b squared, and the other of a cube minus b cube, which will be a minus b a squared plus ab plus b squared. Cancel questions 1 and 2. Now in the third question, I see that they are perfect cubes. So that becomes 64 will become 4 cube and a cube b cube, write it as ab cube. So this is of the format a cube minus b cube. Apply the formula now, which is a minus b a square plus ab plus b squared, and solve it further to get the answer. In the fifth sum, first of all, I see that 3 can be taken out common, and even x raised to 4 and y can be taken out common. So whenever you can take out something common, you must do that. So what is left in the bracket is x cube minus 27y cube. This is a perfect cube. So now this becomes of the format a cube minus b cube, and the formula for that is a minus b a squared plus ab plus b squared. Can it be solved further? Anything more taken out common? Nothing more. So that's it. Seventh sum, I see perfect cubes again. You may convert this first into a fraction and then write the perfect cube, which becomes this. Now from this step you can directly jump to this step as well, because we know that 0.4 cube is 0.064. Since it's a cube and it has one decimal place, its cube will have 3 decimal places and its square will have 2 decimal places. So a cube plus b cube formula is a plus b a squared minus ab plus b squared. So 0.4 squared is this. Now in the ninth sum, again I have a cube minus b cube format. So the formula says it should be a minus b a squared plus ab plus b squared. Now when I do a minus b, I see like terms together, so I get minus x minus y. Now here I have to open all the brackets. So a minus b the whole squared is a squared plus b squared minus 2ab. Here distributive multiplication, so I get this, and this becomes 4x squared. Now the like terms together. I've got x squared here, 2x squared here, and 4x squared here. That becomes 7x squared. Y square is alone, so just write it, and minus 2xy and minus 2xy becomes minus 4xy. Well, when you see a minus sign in the first term inside a bracket, we have to take it out common, so the inner sign changes. So this is your final answer. Now if you want this minus 1 to be absorbed by this bracket, then you can write one more step, which will be x plus y, and whenever minus 1 is absorbed, all the signs inside change. So then I will write 4xy minus 7x squared minus y squared. But there's no need for such a step. You can just stop here. Now in the 10th sum, it's a fraction sum, but the logic is the same. It's a cube minus the b cube, that is a minus b a squared plus ab plus b squared. Remember, it's plus ab, not plus 2ab, okay? Well, here squared, so open the brackets. Remember to square numerator as well as denominator. And even here 2 got cancelled, so you got this. That's it. There's nothing more which can be done. Now the 12th sum, which is IMP. Here we have a power of 6. So let's simplify it. Let's make it a power of 2 max. So assuming a cube to be x, so a raised to 6 will become x squared. 7a cube will become 7x, and minus 8 will remain as it is. The reason why we are doing this is so that it becomes a usual quadratic expression. And now splitting the middle term, 7x has been divided into 8x and 1x, because the multiplication gives us minus 8 anyway. Now remove common brackets, and then right here resubstituting. Now again, this is a formula of a cube minus b cube, and this is a formula of a cube plus b cube. So use the formula. This will become a minus b, a squared plus ab plus b squared. And for this, write the formula, use the formula a plus b, a squared minus ab plus b squared. Here there is 1, no need to write the 1. I see 2 more quadratic expressions here. If they were factorizable, then we would have split them further, but it's not possible to do so, so we have to leave it as it is. Next, in the 14th sum, I see 4 terms, but I see that the first 2 terms are perfect cubes, so we can use the formula a cube minus b cube for the first 2 terms, and in the next 2 terms remove 2x common. Now here a cube minus b cube is a minus b, a squared plus ab plus b squared, and this bracket remains as it is. But now the brackets are same, so take it out common and the remainders in the other bracket. Now check, can you solve it further? Can anything be taken out common? No, because there is just 1 out here. So this is the final answer. Now in the 16th sum, again I see 4 terms, but I notice one thing, that all 4 terms have something in common, a factor called 2. So whenever we can remove something common, we should do that. It makes solving very easy, and sometimes we can't even solve without that. So if I remove 2 out, then in brackets I'm left with this. So this is now an ordinary sum. The first 2 terms are a cube plus b cube, and here also I can remove minus 2 common, so this sign changes here. And a cube plus b cube formula is a plus b, a squared minus ab plus b squared, and this remains as it is. Be careful about the brackets and use them freely. Now this bracket is common, so take it out common and the remaining terms separately out here. There is nothing more we can do to solve this further. There's no formula, there's nothing in common, no like terms, and this 2 which we had taken out common remains as it is in the end. So this is the final answer. So mark the 16th sum as IMP. Now in 18.1 we have to show that 13 cube minus 5 cube is divisible by 8. So what we'll do here is we'll use the formula to factorize it. A cube minus b cube is a minus b, a squared plus ab plus b squared. Now this a minus b is 8. There's no need to solve this further. I know that if one of the factors is 8, then this expression is divisible by 8. Next, the 19th sum, mark it as IMP. Now this sum looks so complicated. If we actually multiply, add, subtract, divide, it'll take a long time. We can use a calculator and yet it'll take a long time. But now we realize the use of these formulae which we are studying. See how easy the sum becomes because of our knowledge of a formula in such a special circumstance. So first of all, it's 5.67 cube plus 4.33 cube, and the denominator is 5.67 squared minus 5.67 into 4.33 plus 4.33 squared. Now we know that the formula of a cube plus b cube in the numerator will be a plus b, a squared minus ab plus b squared. Now this entire bracket and this entire bracket is the same, so it gets cancelled. So ultimately we are left with only this bracket, and when you add them, the answer is 10. Next, now in 5e, question 2, I see 5 terms, But the first three terms, if you notice, can make a formula. The formula will be a squared plus b squared minus 2ab. But where is the ab? Well, the a and b are actually these two terms which will get cancelled. So it is a minus b the whole squared actually. Minus 4 common, so the sign will change here. And not surprisingly, this bracket will be same as this one, but there is a square. So when you take out this bracket out common, one bracket remains here and minus 4 remains, and that's the answer. Now mark the fourth sum as IMP. This could be considered as a type of a squared plus b squared, but I don't have 2ab, I have 27ab. So let's split this. Let's make this minus 2ab minus 25ab, so that it becomes of the format a squared plus b squared minus 2ab here, and this is a formula a minus b the whole squared. Here we can consider x squared as a and y squared as b. Now what is left is this one. This is also a perfect square, and that's the whole reason why I could confidently split this into minus 2 and minus 25, because not only am I able to get a formula out of it, but I'm getting a perfect squared here, so I can use one more formula. This whole thing is a squared minus b squared, that is a minus b, a plus b. Can this be solved further? Anything, nothing. So this is the final answer. Now the sixth sum is similar to the fourth sum. I see that it could have been a formula if there was a 2 out here, that is a squared plus b squared minus 2ab. By the way, in fraction type of sums we don't write ab because a and b would have got cancelled. But I don't have 2, I have 3, so I'll split it into minus 2 and minus 1, so that at least this part becomes a formula, x minus 1 upon x the whole squared. And this is also a perfect square, so again a squared minus b squared is a plus b, a minus b. Next, in the eighth sum, we'll substitute this 2a minus 3 as x and a minus 1 as y, so that it becomes a simple quadratic expression, which is an exact formula called x minus y the whole squared. And then you resubstitute x and y. So this is the x part and this is the y part. Note how the sign got changed here because of the minus sign. And then 2a minus a is a, minus 3 plus 1 is 2. So you get the final answer. Now after this step, we could have directly jumped here. If you can do it mentally without substitution method, it's okay. Next, in the 10th sum, we have done such a sum. First step we'll do is we'll take out the 4 common. So what is left is a square minus a. Now this bracket and this bracket is the same, so we'll assume this to be x, so that it becomes converted into a normal quadratic expression. Now splitting the middle term, minus 5 becomes minus 8 plus 3, because their product is minus 24, which is the same as 4 into minus 6. And now make things common, create the brackets. These are the 2 factors. Don't forget the resubstitution. On resubstitution, I'm getting 2 more quadratic expressions. This can be split further. Minus 1 can be split into minus 2 and plus 1. But this cannot be split further. 4 into 3 is 12. And there is no way I can split this into 2 numbers whose product is 12. So this will remain as it is, but this can be broken down into 2 more factors. So totally I got 3 factors. This can also be factorized, but not by the splitting the middle term, but by a particular formula which is not there in our syllabus. Now if you think that you can split this into minus 6 plus 2, which will give me the product 12, note that 4 into 3 is plus 12, whereas here you're getting minus 6 into 2 minus 12. So there was a sign mistake. not a mistake, but sign problem due to which I could not split it further. Now mark the 14th sum as IMP. The first thing we'll do here is remove 4 common from this bracket, simply because then this brackets will become same. And now substitute this as A so that it looks like a usual quadratic expression. Split this into -6 and +2. Note -6 into 2 is -12, which is the product we get here, so no problem. So we factorize it into 2 brackets, resubstitute the value of A, open the brackets, and we get the final answer. Next, in the 16th sum, I see 4 terms. I can see the first term and the last term are perfect squares, and they are the perfect squares of these 2 middle terms. So this should give us a hint about what type of sum it is. So I'll just rearrange the terms. This will be 3x the whole squared, this will be -8y the whole squared, and these 2 terms I'll put them in a bracket. Now they look similar, don't they? That's the whole point. This is a squared minus b squared is a plus b, a minus b. So now this bracket and this bracket is same. So take it out common, and what is left right here? Here nothing is common means 1 is common. So write that. I mean nothing is left, so 1 is left. So write that. Next, mark the 18th sum as IMP. So here, since there are brackets involved, there are many ways to do this. What I prefer is remove the LCM and get the denominator same and common. So into 4 into 4. So the denominator becomes 16, which is a common denominator now. So now we have to only worry about the numerator. I won't solve the denominator anymore. Let it be 16. So my focus is on the numerator. Convert these into perfect squares. So this is a squared minus b squared. Open the brackets inside. So a squared minus b squared becomes a plus b, a minus b. Note how this sign changed. Get the like terms together. I'm getting 2 brackets. Now we should never leave minus sign as a first term in a bracket, so I'll just flip it. I'll write 5b minus 4a. We could have removed minus common here so that the inner sign would have been changed, and that minus sign could have been absorbed by this, and this could have been flipped. But why complicate things? Just leave it like this, and that's the answer. Now in 20.1 and 20.2, we have to solve this further, find the value using the formulae. This is of the type a squared minus b squared. So it will become a plus b, a minus b. This becomes 1000. So now multiplication is so easy. We just have to add zeros, and that's the answer. That's why formulae are useful sometimes. Now here a squared minus b squared is a plus b, a minus b. Interestingly, this bracket is same as the denominator. And so the only thing left is this, and the answer is 10.